Because of the high automation for the industrial industry, we have very entry-level flight skills requirements. On the other hand, instead of the actual hands-on flight skills, what's more required from the pilot is more of the managing ability. It's knowing, having more industry background. So what altitude, what frequency, what overlapping rate are you actually setting on the drone to capture the most efficient and precise geomatics data for site? At that point, it's more of the consideration from the pilot. It's knowing even where to set up on the location. If you need to collect ground control points, where to actually set your ground control points. Even what the format of the GPS are you actually using? Are you working with benchmarks? Depending on the site, what type of sensors do you need? Do you need your regular RGB sensors with just the depth perception for geomatics information? Or do you need LiDAR sensors? For example, we had a recent mission for large development land up north, and it was fully covered with trees. So we did the first couple flights with photogrammetry, which worked great when you are in, let's say, GTA region, when the land is cleared with minimum trees. Photogrammetry, which is using the depth perception from the camera to collect your topography information. So we did those missions up north, and we came back with the data and realized the data was completely unusable. Why? Because it was capturing the treetops, not the ground level, because of the limitation of photogrammetry. So we had to swap with the LiDAR sensor, which uses a laser which can penetrate through the treetops to get to the ground level, and redo the whole survey mission again. So you will see that depending on the location, depending on the environment, even depending on weather, right? Is there snow on the ground? Is there water? Are you working with lake or any kind of water scenario? They all provide different requirements on the drone settings. So at that point, your focus is not so much on how to manually fly the drone, but it's more about understanding the equipment capabilities, understanding more of the professional industry background to how to deliver, how to capture usable data, accurate data, and deliver results. So on this note, like I said, I mentioned the LiDAR sensor, which we're actually seeing more. So this month update is we're actually seeing feasibility with using LiDAR sensor. In the past few years, we were always considering adding a LiDAR sensor on the drone, but the cost back then for LiDAR sensor, you're looking at $200,000 to $250,000 plus. That's just the entry level to get a LiDAR sensor. And I'm not even talking about processing the actual data collected from the LiDAR sensor, because there are actually a lot more to be processed than your general photogrammetry data. We just didn't have the demand to actually get into that price range. Now, this year, we were actually able to implement a LiDAR sensor. Obviously, we have the Matrix 210 to begin with. So adding a LiDAR sensor, we're looking at the cost range of $50,000 plus. So it's more of in the feasible range of adding the LiDAR sensor. We'll have a couple of separate industry webinars discussing specifically for LiDAR sensor applications. So stay posted for that. There's also another update I'd like to share with everyone. ARM US, Rocky Mountain Unmanned Systems, they're based out of Burlington. They're one of our equipment partners. They're actually hosting a tech week where they're actually discussing LiDAR sensors. They also have other robotics applications, Spot, for example, and even different drones. There's AlteX Evo 2 RTK. So if you're interested in industrial applications and different technologies, this is a free event for all, the Tech Week. Make sure that you check out ARM US or just sign up for AlteX Academy's newsletter. We'll also distribute the link through our newsletter next week.